Okay, the displacement in meters of a particle moving in a straight line is given by s is equal to 1 over t squared, where t is measured in seconds. So find the velocity at times t is equal to a, and 1, and 3. So if you find that, if you just replace a with 1 and 3, we can get our numerical values for velocity at 1 and 3. So ds over dt, right? When t is equal to a, by definition is the following. H is approaching 0. We have our function a plus h minus f at a all over h. So let's replace f with this function here. So we have the t will be replaced with a plus h squared, a squared all over h. Okay, so let's, instead of having this compounded fraction, let's make that h, divide by h times by 1 over h, like that. Okay, then we have a plus h squared minus 1 over a squared. And let's combine the bracket. That's the common denominator, and on up here we're going to get a squared. On top of that we're going to get a plus h squared. Okay, just adding rational expressions. So look at the top, just difference of squares. So we get a minus h, a plus h. Okay, note that that bracket right there is minus h. So if you reduce, you get a minus 1. This whole bracket becomes just a minus 1. Now let's replace h with 0, and we get a minus 1, 2a plus 0, a squared, a plus 0 squared. Okay, so we get a minus 2a, a to the power of 4, which is minus 2 over a to the power of 3. Okay, so that's a derivative. Okay, that's ds over dt when t is equal to a. Now we also have to find 1 and 3. So ds over dt when t is equal to 1 is just going to be minus 2. Okay, so it's the units are meter per second, and the velocity of the particle at 3 is minus 2 over 27. Meter per second.